Today we're going to take a look at a little bit of exponents, and we're going to continue with some of the things that you were doing in your homework last time, where you're distributing things maybe, or simplifying quantities and combining like terms, and we're going to do it by way of talking about order of operations. So we're going to start with the exponent part of it because we're going to use some of that within the order of operations. So, exponents, what are they? Well, the repeated process of multiplication, so when we multiply 5 times 5 times 5 times 5 times 5, has a shorthand notation. We can use shorthand and we can abbreviate the notation of multiple multiplications by using exponents. So for example, if I had a to the n, this would mean a times a times a n times. So our first example, number 1, says 3 to the 4th. And what this really means is 3 times 3 times 3 times 3. And because we can do the multiplication, so to speak, in whatever order is helpful, it's kind of nice to multiply these in pairs. 3 times 3 would be 9. So this ends up with 9 times 9, or what? 81. It's 81. Okay, so somebody asked a question on how something was graded on their homework, and I went off on a tangent actually because it wasn't what was actually being asked, but I mentioned it. So I'm glad I put this particular example in here. I want you to understand that when you see something written like number 2 or written like this, these are not equal statements. These two things are not equal. Okay? Obviously, you're looking at it and you're saying, okay, well, they're just missing a parentheses, so what's the big deal? Well, the big deal is that with the parentheses there, like I've written number 2, this means negative 2/3 times negative 2/3. Without the parentheses there, this means negative. I should have put a 3 down here, or 2 down here too. Sorry, that part I wasn't trying to confuse you on. The negative, and then it's 2 times 2 and 3 times 3. I know my structure of my numbers is not exactly the same. It's equivalent, it just doesn't look exactly the same. But what's the real difference in what I wrote? Do you see it? What's really different? Okay, you're seeing the structure difference. That's true, but that's not what I'm getting at. Something else.
The 2 stays negative, or like the top. The numerator stays negative.
Good. Okay, so what you should see here is that there are 2 negatives here. Do you see that? But there's only 1 down here, right? And the net result of that is exactly what Megan said. My example on number 2 would actually create negative 2 times negative 2, which would become a positive 4. And I've got the 9. But the result of doing it without those parentheses would actually leave it as a negative 4 out of 9. Okay? And if you have like a TI-84 calculator, even some of your scientific calculators will probably have the same issue. If you put this in, it's going to do the same thing. You put the parentheses around the negative number and you square it, it's going to become positive. You don't put the parentheses around the negative number, it's going to stay negative. Because your calculators, for the most part these days, understand order of operations as well. Those parentheses are really, really important. Because the concept means, the notation means something conceptually different. Okay, so please be careful on your use of parentheses when you're trying to indicate that the whole quantity is being squared versus just the number part without the sign is being squared. All right? Okay. Where we're going to spend the most of our time, we're going to use this stuff with evaluation with exponents, but where we're going to spend the most of our time is on order of operations. Okay. So who has seen the acronym PEMDAS before? Just a raise of hands. Okay, we've seen it before. It's pretty commonly used. There's a couple other ones used as well, but this is the one that's still kind of most prevalent. Sometimes people will learn it as please excuse my dear Aunt Sally to remember it. Maybe that's you, maybe not. There is sort of an inherent problem with the way that this is structured, so I want to actually write it out a little differently than maybe you've seen it before. So you'll see my P, and I bet you know what the P stands for, and it's not P for please, like in the please excuse me. That's not really what it stands for. What does the P stand for? Parentheses. And I'd like for you to write down what that means next to it, because this causes parentheses. That doesn't look right. Ah, yes. There we go. Okay. This means simplifying inside of them. Simplify the inside. Now, sometimes you can and sometimes you can't. This example on the board behind me from when you guys were asking for your homework, this one, the negative 5x and the 3w, they can't be simplified. Okay, so this doesn't apply to this problem. I can't do anything with the parentheses. But sometimes it can, and you'll see some examples as we continue on in today's lesson where there is something inside the inside the parentheses that can be simplified. Okay? What does the E stand for? Exponents. And that's why I wanted to at least briefly introduce them today. We'll talk more about them, a lot more about them on Tuesday. Okay? MD or DM. So the reality is that MD makes PEMDAS sound easier to say, but PEDMOS would have been just fine. Okay? The D and the M do not have an order. Either order is perfectly legit. So what is the M, what is the D? Yeah, it's multiplication and division. So I'm just going to write down multiply, divide. And it doesn't matter if you've got multiplication and division, which one you do first, okay? Interchangeable. But what does matter is that you move from left to right. And this is more about like the conventions of math. There's nothing inherently that says we have to move from left to right. The purpose and the reason is because that way when Chloe sees the problem and when I see the problem, we both read and understand the problem the same way. So somebody somewhere along the way structured it to do this. Okay, this is a man-made thing. This is not inherently God-created, okay? It's just not the left to right business. Did you know that there are languages that do not read from left to right? Oh yeah, Chinese write from left. Start from the right and go left. I had a office mate in grad school who's from China. Okay, so that is a man-made convention. And what is true about multiplication and division is the same for addition and subtraction. So we legitimately can say PEMDAS, PEDMOS. We could say PEMDAS. I can't even say the SA at the end. We'd have to say SA at the end. PEMDAS. We could do that. We could switch the S and the A. We could do PEDMASA. Can't get an extra A in there is the problem, right? That's the hard part. Okay, so the S and the A, just like multiplication and division, are interchangeable. What do they stand for? Yeah, it's addition and subtraction. I'm just going to write add, subtract. And the convention is the same. We move from left to right. Okay, I know you've seen operations before. I know you kind of know this, but order of operations trips people up like all the time. So I want to make sure that we get that sort of concrete before we move on to any more complicated numbers and operations and variables, so that we're all on the same page. All right, so we're going to do a whole bunch of examples. These are our first two. I'm going to do the first two with you on the board, and then we're going to do some you writing stuff like we did last time, okay? So first one on the board is 6 squared over negative 2. Okay, so what operations do you see present in this problem the way it's presented? Exponents and division. Two operations, right? Which one comes first? Exponents. So super important. If you do division here, you will not get the same answer that I get. So exponents would mean we're going to do the squaring of the 6 first. So what is 6 squared? 36. Excellent. And then I can do the division. What is 36 divided by -2? It would be -18. Very good. Nicely done. Sometimes people like to reduce things before they do exponents. Can't do that. Got to do the exponents first. All right, what operations do we see present in number 2? Multiplication, subtraction, division, and addition. We got like all 4 of the basic operations, right? No exponents, no parentheses. We got everything else. So what am I going to do first? What is the very, very first computation in this problem that I'm supposed to do? Multiply the 6 times 2, okay? Because we can do multiply, we can do divide, but we're going to do whichever one comes first, moving from left to right. That's the 6 times 2. So what is 6 times 2? 12. What would be the next operation that I need to do? Right, the 16, or in this case it's really -16. Hey Patrick, thanks. -16 divided by 8. Because it's multiplication and division all in the same time, basically. What would that give me? It would give me -2. So I'm going to write a -2 or -2 is what it looks like. And then I'm going to shift that over here. There's my 2. And then I have +2 at the end. Correct?
Yes.
Yes. Now I still have addition and subtraction listed here. So if you were like really thinking order of operations, I have to add before I subtract, you might think you have to start at the end. But that's not true. We're moving from left to right. So what is 12 minus 2? It's 10, and then 10 plus 2 would give me actually the 12 back. So this problem would give me 12. Okay. Any questions on those two before they get a little bit more challenging? All right, we're going to do the same thing. It is going to get real challenging real quick, and I think the next 2 examples are maybe my two most difficult. It's just the way it happens sometimes. So what I'd like for you to do is like we did last time. I'm going to flip my screen. I'd like for you to do the 2 problems to the best of your ability, and I'd like you to compare with someone. There's a real good chance as you compare today that you're going to find some different answers between you and your partner. You're probably going to make some mistakes. I make mistakes on order of operations sometimes too. Just because I get moving too quickly, I forget and I try to do something I'm not supposed to do in the wrong order. It happens, okay? So compare, see if you can reconcile the differences and figure out which one is the right approach. And then we're going to do volunteering again today. We're going to write on the iPad. Those who volunteered yesterday, was it like scary hard? No? Did I embarrass you? Oh, I hope not. Okay, good. So that means that we should have different volunteers today, hopefully, who are willing to just write on the iPad for just a little bit, okay? All right, here's our next 2 examples. I think 3 is the messiest looking one we're going to have today. know, I can see a few of you are finished. So if you are, and when you are, go ahead and compare notes with somebody sitting nearby you. I think you're going to have to move, McKaylee. You're just a little too far away from everyone. Just a little. Josh is too. See him back there in the corner? You want to volunteer? Lovely. That's okay.
Pretty much, yeah.
Okay.
Is that right?
Let me see. I've got an answer. I should look. Hang on.
No.
No, you're good.
Okay, can I just start writing?
Just I made it bigger, right? So
Okay.
you can zoom in and zoom out so that you can write big, basically.
Okay.
You can use this tip or this tip.
Okay.
You can't touch the screen with your hand while you're writing, so it can't be like when you write on paper, okay?
Okay.
Your call. Oh, but you can use your finger too if you prefer.
Yesterday, whenever you said you can't.
Okay, Alexandria is going to show us what she has. Compare what you have to it. See what you think.
Can I move the screen with my finger?
2 fingers. There you go.
Okay.
Okay, did we get a -8?
Yeah.
Yeah, that looks pretty good. The only thing that maybe I would correct or change is the equals part at the end. We talked about last time, remember how it looks like the 4 times the 2 is equal to what we had before, which was
Yes.
the 6 and
Yeah,
8.
it's a separate thing.
So, yeah,
Okay.
totally cool. Let me show you how I would suggest to fix that. Easy stuff. I would actually, because the way you've already done it, I would just move this down here,
Okay.
and then we're good to go. Sound good?
Yes.
Just to make sure
That
it's
makes
clear.
sense. I'll write that down.
All right, any questions on that one?
I'm kind of confused how she did that. Can you do it one more time?
Sure. How about do you want to talk you through it, or I can?
I can talk through it if you want.
Okay, so
That's
Alexandria
fine.
is going to explain if you're still questioning too. What did she do?
So at the beginning, I did the inner parentheses first because in my mind, those ones are the first things compared to the bracket ones. So I did that, and then it equaled -6 or -1, and then I multiplied that by the 6 because I used PIMDOS, and you do multiplication before you do addition, and then I added 2 to that, which got me to -4, and then I multiplied that by 2, and I got -8 as my answer.
Very good description. Nicely done.
Thank you.
I like how Alexandria described the fact that the parentheses are sort of inside of the brackets. It's a really good way to think about them. We start with what's inside, like the most inside thing, and deal with that and work our way outwards. That's really good. How about a volunteer for number 4? Thank you, Patrick. Okay. So you can't touch the screen with your hand when you write. You can use
Oh.
either tip or your finger.
Okay.
Oh, it's still in purple. That's okay, though. That's
Sorry, that looks like a 25.
okay. Okay, it's a 75. Everybody good with that? You wrote a 75 there? Okay, so the answer is 77. You're right. Good job. Okay. So he wanted this to be, I'll clear it up just in case there was any confusion. A 75. Yeah? All right. Everybody good with that one? So he started with the exponent, right? Because there's an exponent in this one. 5 squared would be the 25. And then after we get rid of the exponent, multiplication would be coming next. That's the times 3 part. And then the last step is always the addition and subtraction. So we add the 2. Excellent. All right, let's try a couple more. 6 might have as many steps as the one that Alexander did for us on number 3. parentheses. So simplify inside the parentheses first. Yeah, Karen asked a good question, and actually I'll show you an error that a lot of people make on number 5, but parentheses and what's inside of them simplify before you deal with exponents. Inside the parentheses first. Are you okay? So as you find your answer, compare with a neighbor. See if you arrived at the same conclusion. Connor asked on number 6 if you should leave the answer in fractional form or change it to a decimal. If it starts in fractions, we're going to end in fractions. That's how we're going to treat that, okay? So fraction form. Okay, as you're comparing, I was thinking this might be helpful and make you feel less scared to volunteer. I'm going to give you the answer, and then you guys can tell me if you're comfortable to volunteer. So this one should be 27, and this one should be 5/4.
What? What's that decimal?
It's 1.25.
Okay.
Yeah, but you've got to be able to work inside of fractions for me, okay? What's that?
Simplify the fraction.
How would you like to simplify it, Macy? Like, what did you have in mind?
Like, I was just thinking, like, how we've been doing, like, simplifying, because I got 20/16.
Yes, and then you would simplify it to 5/4.
just
Yep,
making
you
sure.
got it. Making sure that we're on the same page. Yep, that's right.
So,
Preston.
on our homework and stuff, you want us to put down fractions instead of decimals?
We haven't talked about decimals yet. As far as I'm concerned, you don't even know what a decimal is. Oh, I know it's terrible, right? You'll survive, I promise. Okay, who would like to do number 5 for me?
I'll do it.
You'll do it. Thank you so much, Karen. Okay, so I'm going to change it back to black. All right, so you can make this screen a little bit bigger. You can use either side of the pen, and then, or you can use your finger. All right, Karen's going to show us what she has. Follow along, see if you have the same thing. Looks good. Yes, ma'am.
I just have a question.
Yep.
So I did the same exact thing, but if we did that in our homework, would we be counted off for not putting the parentheses over the 9?
No.
No?
You would if the 9 had like a negative in it,
Okay.
but not if there's a positive.
All right.
Good question. Yeah, how important are the parentheses? They're really not very important unless there's a negative involved or there's an operation happening inside of it. Yeah. Okay, so let me make one comment here, and I think that this is maybe what Karen was asking about when she first asked her question, and it is a really common question to think too, is if I had this, and maybe even if it didn't simplify, like maybe it said 7x plus 2, right? So I couldn't actually combine the 7 and the 2. How do I rewrite it differently? And a misconception, so this is not equal. If you're writing this down, you make sure that says not equal next, okay? This is not equal to 7 squared plus 2 squared. And let me just verify for you really quickly that it doesn't work. What's 7 squared? 49. What's 2 squared? 4. Is that 81? No, it's not. So we do not have any properties that distribute exponents like that. We're going to talk about exponent properties next time, but you will not see a property that does this, okay, because it isn't true. You can't distribute them like that, okay? We'll talk about what you can do later, but for right now, we're kind of putting that on pause because it's irrelevant at the moment, okay? All right, who would like to do number 6 for me? Thank you, Jack. Okay. So again, you can't touch the screen with your hand as you write. You have to hover. You can use either tip or you can use your finger.
When you told me that, I just simplified it by 4. I didn't even think about doing 4.
Good job.
That's a 5 on top.
Yeah. I think I made your screen a little bit too big, so I kind of weirded you out. I'm sorry about that. It wasn't my intention. Okay. So, in fact, it's a little bit better. Just make it a little bit bigger for us. All right. So we're working within the top and the bottom separately first, correct? Now, that might feel a little bit funny because, I mean, aren't we supposed to divide before we add? Or aren't we supposed to divide before we subtract? Did anybody think that? Sometimes people do. It kind of doesn't look like it. While they're not there, there are understood parentheses around the numerator and understood parentheses around the denominator so that you simplify those pieces first, much like you would simplify parentheses first before you do the division. So very well done. Yes, we're not going to move this into decimals right now. We're going to leave these with fractions for the moment. We are going to reduce our fractions, like Macy was asking about reducing. So when we got to the 20/16, we want to pause and ask ourselves, is there a way to make it any simpler? And we did get it down to the 5 divided by 4. Okay? Nicely done. Let's try a couple more. Okay, compare with a neighbor. Double check that you have the same ending spot. Thank you.
5, 6,
All right, I'm going to do these last couple with you so that I make sure to get us finished up in time to take pictures of your papers, okay? So on number 7, what are we going to do first? Which operation? Going to do the multiplication first, even though, man, it would be nice if we could do the addition first because those denominators match, right? That'd be super nice, but no. So we're going to do the multiplication first. I've heard like bits and pieces of what I've heard you guys saying. You can make the denominator 20. That's okay. If you just multiply the 5 and the 4. You could also make the denominator a what? Like what could you do instead of making the denominator 20, just multiplying across? Yes, you're right, Sarah. You could actually do this and reduce it first if you prefer. So they both divide by 2, right? The 6 and the 4. So this would become a 3 and this would become a 2. So it doesn't matter. It's just another option that keeps the numbers a little bit smaller. If you do this, you'll end up with 3 over 10 over here. If you don't, you end up with 6 over 20, right? That's okay. They need a common denominator now to be added, right? So the way that I did mine, the denominator that's the smallest would be a 2 here. Yeah? Well, I said that wrong. It would be a 10 because I multiplied by 2, which is what I meant to say. Sorry about that. So I would end up with 2 over 10 plus 3 over 10, which would give me 5 over 10, which would reduce to 1/2. So this is only one way to get to 1/2. Okay? If you have another option of how you did it, that's wonderful. What operation are we going to do first on number 8? Divide. What numbers are we actually going to divide the way that it's written? Good. We're going to divide negative 44 by the 11, which means the 6 minus is going to stay at the beginning, right? So what is negative 44 divided by 11? Negative 4. Good. I heard somebody say that negative very clearly. So I have 6 minus negative 4, which is actually 6 plus 4, or 10. All right, any questions on that last one?
Yeah, so I just, like, I saw the minus and the minus, like,
Mhm.
and I just put a plus, but I still did 44 divided by 11, and then it's just 4.
Yeah.
Like, is that
That's okay.
messing up on other
Nope,
numbers?
it's not. You could actually, Karen, you could actually interpret this as though it says -1 times negative 44 and think of it that way as well. Because it's minus a negative, which is actually multiplication kind of a property.
For number 7, I just feel like I made this big mess. Like, I still got the same answer, but, like, I don't know.
If you use just multiplication across, it will be messier. Like you would have had 1/5 plus 6 over 20. And then get common denominators there, but you could actually end up with a denominator thinking that it's 5 times 20 and get it to 100. So there are definitely ways where the numbers get much larger and are messier. They aren't wrong, they're just a different way of doing it. All right.